Having opened the Simulink windows, now we are going to transform the system from the nodes that we have, this one, into the system that we are modeling right now. Let's see if I can lower this. Maybe there. Alright, so here we have. First of all, we're going to need this one, so we move it over. We are going to need a gain over here, and over here also. And we need the integrators. Okay, so we need one more. We need also the scopes. We need two of these guys. So what we need now is to, we still don't have the summation point. So let's make it a little bigger. How many terms do we need? The summation point, it has a double click. It has 1 plus for the constant, and it has 2 negatives. So there we go. Okay, so now we'll click over here and then go there. Yeah. And then it's making the suggestions to click on one element, hold the control key down, click on another, and it joins really nicely. Okay, that one, this control I for invert. We need to invert this one, so the control I, and then this one too. This thing was to pick the, oh no. See, it doesn't red if you don't do it correctly. Yeah, oh, it's still not right. There you go. So this one in here, picked up from here, like this. You're looking at your picture. Yeah, there we go. And then we are finished. If we try to run this, it won't run because it does not know what the physical parameters are. In here, you need 1 over m. Okay, make it a little bigger. Here we need b. Here we need k. Computer has no clue what these values are. So including this is F. So if you click on the scopes, the display, see here, there you go. What will happen if we try to run this? Just run. We know it has problems, and in fact it didn't let us go by. It really catches it and tells us. See what it says? Read what it says. If you read what it says, see, it tells us undefined function if, undefined variable n, and it will do it for every single one that it doesn't know. So what we need to do is to give it some values, and that's what will make the simulation run. See, in fact, it puts it all in yellow and it doesn't want to go. So what you need to do is to come to this window, and then you say if is equal to 10, yeah, and then you have that m is equal to 1, let's say, that b is equal to 2, and I have given you some values that may work. Case 30. If you initialize all these things, yeah, if you initialize this and you run it again, guess what happens? See, it runs. If you click the binocular, there are both the simulations, both the position and also the velocity. See, this is the position, and this is the position, the velocity here. So, and then you complete the simulation from scratch, basically, to the point where you make it run. Now, you can also do this by creating a file to initialize the simulation. And of course, we could try that too. How do you actually do that? First of all, we have to go to the MATLAB window, and if we put clear, well, before that, so you can see, we say who is, we don't see, so we clear the workspace. And so if we run it now, it will not go. See, if you try it now, see, if you run it, it's going to give you the same errors. But if you go now and create a file where you say m is equal to, no, what was f is equal to 10, then you say, no, not that one, it's gotta be capital. Then you have m equal to 1, b is equal to 2, and k is equal to 30, like that. Yeah. Now here, if you run this file, you say you say save file and run. You can save it in the desktop, I would suggest. Send it in the desktop under, you can say, example. And if you try that, save it, you run this file, add this to the path, and says run the example. See what it did over here? It put the values. And when it did, then here, let's see if we, unless we have something bad, we should be able to see it running. In fact, we are. See here? Okay, so that way we got it running by initializing the values directly on the window, or by the initializing the values on the file.